I just have one last question that's a little bit off the topic of prediction, but I'm really curious. So it's relevant to prediction, but a lot of my work that I do now has to do with data sharing and data preservation. And in the digital age, this is very difficult because formats change and people aren't very careful. And in cases like this, it's almost easier if you have acid-free paper and people keeping track of the books. But I'm curious, if you had to guess, what fraction of astronomical observations that were once recorded on paper in, say, the 16th century or the 17th century are still findable today if you tried, if you had many Owen Gingeriches to go look for them, if you could find them? Is it a tiny, is it 1%? Is it 50%? How much of this stuff is just lost forever?
I want to show you something else.
Owen once told me that he chooses what to put in the safe by what will fit in the safe and be preserved against fire. So this poor book is on the floor.
You missed the key to that.
What's that?
It goes according to the value per cubic centimeter.
Right, sorry.
This was an attempt made by an author to collect all the astronomical observations that had been made from the beginning of time up to 1630.
I'm glad I asked. Okay.
All right. Now, this doesn't have any of the observations made on clay tablets.
Okay.
Because at the time they were doing this, nobody knew about that huge archive. Mm-hmm. Nor does it have any of the Chinese observations in it. But otherwise, it has the observations that were made on paper. And what's interesting is that
that appeared to be in Greek.
Yes.
Yeah.
Yeah, that's from a Greek source.
Okay.
Here begins the time of Tycho Brahe.
Okay.
Who is the great observer who in the late 1500s, for instance, made this instrument, which was, that's the first one he made, and it was unsuccessful because too big.
But he wanted to measure the positions of stars very accurately.
But look,
with that? Yeah.
This is for all of the observations made prior to Tycho Brahe.
In your hand there, on your right hand.
There, yes. These are the observations made by Tycho Brahe.
Oh my gosh.
And these are all the observations he could find that were made between Tycho's death around 1600 and 1630. So here's another 30 years of observations.
Right. And
Look
Tycho,
at the impact that Tycho Brahe made.
And this is within, what, 30 years or more?
Approximately.
Yeah, okay. Yeah.
So that it just made a revolution in astronomy. It made it possible for Kepler to do his work because he had access to those.
I'm so glad. I was going to ask you before, why did you leave out Tycho Brahe in our story? And now I'm so glad that we have
There is
it.
Tycho Brahe.
Yeah.
And, we had another surge in data when Harvard Observatory started taking photographs. We're starting back around 1880.
Right.
And those plates that Henrietta Leavitt was working on, for example, had more than 1,000 stars photographed on them. So at the moment, the plate collection covers a span of about a century.
Right.
And there are 500,000 glass plates over there.
And it's being completely digitized.
Being
in the DASH
digitized
project.
at the moment. We are now living in a third surge of data
Yeah.
being made by these various photographic or photoelectric techniques. And the amount of data comes in computerized form.
That's right.
Otherwise, you couldn't handle the amount of it. So it's a time of huge discovery, as it as it was each of these times when the observations took hold in this fantastic way.
Reading about the John Snow Cub.
Learn more at predictionx.org, where you can stay up to date on all of our latest offerings and interviews.
Cub.